Hi everyone, I'm Ken Fridley, Field Application Engineer for Greenlee Communication. Today we're going to continue on from our overview of the DataScout 10G and begin talking about the Ethernet application for the DataScout 10G. Now this is just an application that's loaded on the DataScout 10G. It interfaces with the Ethernet interface. So to open that up, what I'm going to do is I'm remoted into the device on my tablet right now. I'm just going to tap on the Ethernet application, and what we see is that the application is now opened up. It's just that fast. The checking gig E symbol in the upper right hand corner went away, which indicates that the Ethernet interface is ready to go. And now what we can see is the user interface is very, very easy to read. We say use it like a book. Read from the top left corner, work your way to the bottom right hand corner. All your settings are on one screen. You never have to go into menu after menu after menu. Everything that we're going to do will stay right on this one screen today. And then your test results will pop up over top of this screen. So if you're a new technician and you're not familiar with Ethernet, this is a very simple to use, fast to learn application for Ethernet testing. So what I'm going to do is up at the upper left hand corner, we can see that we have port A is selected right now. If I wanted to switch to port B, now port A is your transmitter, port B is the dedicated loopback port. So the nice thing on this is that if you're transmitting on one port, going around a ring in the central office and coming back to yourself or on a point of presence, you can use the DataScout 10G to not only transmit but act as a reflector as well. So it is a dual port up to 1 gig. So port A right now is showing that I am connected to copper 100 meg. Now on my test setup I have port A and port B connected together. So that allows me to transmit out of port A into port B, then reflect back on myself. So right now we default to 100 meg when the unit first starts, but if we wanted to change that to 1 gig, what we're going to do is we're going to tap on the copper 100 meg button, and then we'll go ahead and select copper 1 gig because that's the port that I'm using right now. Now the unit will display that you have a port B mismatch because it sees that port A and port B aren't operating at the same speed. That's okay. We'll just say okay a couple times here. And then we'll go to port B and we'll select copper 1 gig. Now at this point, the link's going to automatically auto-negotiate. It's going to come up and it's going to show that the link is active on both port A and port B. And you can also see that we're showing that it's copper 1 gig full duplex, FDX. So if it was half duplex, it would also display that as well. So that way you can make sure on a copper circuit, if you have auto-negotiation set up incorrectly, it'll always auto-negotiate to half duplex. It's a good way of telling to make sure you don't have an auto-negotiation issue. So now since we're on port B right now, I'll go ahead and explain the reflector portion of port B. Across the top we can see that all our information is right up front, frames transmitted, frame check sequence, errors, anything like that, anything that a person acting as a reflector needs to see. We can also have different loopback modes. So we can turn on and off the loopback, we can reflect just swap the MAC address, we can swap the MAC and the IP address. So if we're doing layer 2 or layer 3 reflection, we'll do that. And then also promiscuous mode. So when promiscuous mode is off, only the traffic coming in addressed to the DataScout 10G as a reflector is reflected back out. So no keep alive frames or anything like that that'll cause a routing issue. When promiscuous mode is on, whatever comes in gets reflected right back out. To clear statistics, you just tap on clear statistics. Let's go back to port A here, and we'll go over some of the features of the actual traffic generator. So we have in port A, destination, source address, VLAN, length and type, MPLS, IPv4, IPv6, and the payload. Now, this is the same frame structure as a standard Ethernet frame. So the nice thing is that if you're a technician, you can read this right on the front and know exactly what's going on. I'm looking at this now and I know my destination address and source MAC address are on, but my IPv4, IPv6 is off, it's gray. That means I'm transmitting layer 2. Anything that's active is green, anything that's inactive is gray. So to set my destination address, I just tap on destination address, and what we can see is that there's a couple really quick buttons here. Again, thinking like a technician. So say I'm doing dark fiber testing and I'm transmitting out to port A to a loopback plug and coming back to myself. We'll do that with 10 gig here in a second because I have a loopback plug on that port. In that case, you would just tap on set to port A, and you'll notice that the MAC address on your screen immediately changes to A. So your technician doesn't even have to know what MAC address the device is. If they're doing dark fiber testing and they're going out to a loopback plug and coming back again, simply tap on set to port A. Now in our case, because we're transmitting to port B as the reflector, I'm going to go ahead and tap on set to port B, and you'll notice that it automatically set it to port B of the port. Now we could, if it was another unit at the far side, different model, we could just tap on that button and it would actually bring up a screen and you could manually type in that MAC address. In this case, we're going to use our local address, so I can just tap on done, close out that screen. Now once that's done, I can go ahead and tap OK. Source address is automatically set for you, so you don't have to worry about setting that. It's always green to let you know it's done. If you were transmitting VLANs, so if we tap on VLAN, it brings up the VLAN information dialog. And to turn on a VLAN, now we'll support in this software option, we support up to 2 VLANs. In the future release, we're going to support up to 8 VLANs. So in this case, I'm going to tap on VLAN. That goes green. It immediately sets the tag protocol ID to 8100. So nice thing on that is that if I was to activate a second VLAN tag, so we're doing Q and Q or stacking, VLAN stacking, I turn on that second VLAN, you notice your tag protocol ID immediately reversed itself. Because we find that a lot of technicians that are new to Ethernet, they get their inner or outer tag protocol IDs set wrong. And that causes issue when you're doing testing. So we make it very simple. We automatically do that for the technician. So in this case, I'm going to go ahead and turn that back off again. Notice that it went back to 8100 in the first tag. I can set whatever priority I want. I can set my discharge eligible, so I'll leave this set to priority 0 for right now. I can set my discard eligible indicator flag. I can put in my VLAN ID number as well. Once that's all done, I simply say OK. Now you notice that the VLAN is green as well. My length and type is always automatically set, depending on if we're doing Ethernet 802.3 or Ethernet 2 framing, it'll automatically toggle back and forth. So it's automatically set for the technician too. One less thing you have to think about. MPLS in this software option is not enabled right now. It's coming in a future software option, but you're going to be able to do MPLS tagging just like you do VLAN tagging as well. Moving over to IPv4, IPv6, if we were doing layer 3 testing, now what you'll notice is that says IPv4, IPv6. So most competitors, you have to purchase IPv6 as a separate bolt-on software option. We don't do that. IPv6 is here. People are using it. We include it in the base price of the unit. So not only do you get IPv4, you also get IPv6 for the same price. So if I was going to activate layer 3 testing or IPv4 testing, I just tapped on my IPv4 button. I have IPv off. I hit that down. And then we'll go ahead and we'll bring up that screen. And now I select whether I want IPv4 or IPv6. In this case, I'll go ahead and do IPv4. And notice now I can set my time to live, my source address, my destination address, or I can also say get my source IP. Now, what we do is we go out and we query the network and we'll get the source IP from the DHCP server. Now, for the type of service, DHCP, if you're doing that type of header information, if you tap on that button, we bring up a screen and we show the technician not only in hexadecimal but plain English too. What's the assured forwarding behavior? What's the class selector group for, or the expedited forwarding group? So that way you can just select whatever you need and you don't have to worry about remembering what the hex address is, what it does, right? So I'll go ahead and do OK. Now in this case, because we're going back to ourselves and I'm not going through a network, I'm going to go ahead and turn off IPv4 right now. Just make it a little easier. So we'll tap this up, we'll say OK, and I'll go back in and I'll turn off my IPv4, so that way we go back to layer 2 testing. So that's it. From a frame structure standpoint, that's how easy it is to set up a test. Now you'll notice in the lower middle left corner it says quick test. That's BERT. So typically when you're testing, you want to make sure your configuration is correct first. You think you put in the right MAC address, right IP address, but if you're going to do an RFC2544 test, you really don't want to run a full test. It may last a half an hour, 7.5 hours if you're doing a full test. So in that case, what you'd want to do is a quick test, which is just a simple BERT. Send some traffic to the network, make sure you're getting everything back, and if you are, then you're ready to test. So we'll start with a quick test right now, but you can also use this as a standard BERT, because it's really the same thing. So I'll go ahead, I've got my duration set to 30 seconds, my frame size is set to 1518 for maximum MTU. We do support jumbo frame up to 9600 bytes. Remember, anything over 9600 is a super jumbo, so we test up to 9600, which is jumbo frames. What if I wanted to do random frame sizes though? Notice that my button says fixed right now. If I tap on that fixed, it's going to turn off and it's going to go back and it's going to change to random. Random means it's going to assign a certain number of frames from smallest MTU all the way up to maximum MTU, spread them equally and randomize them across the network, and then it's going to make sure that it can pass all the different frame sizes back and forth. So in this case, we're going to go ahead and say random fixed. So I'm going to go ahead and start my test now with a 10-second duration. So we'll hit start. Now notice on here that I haven't even left this screen. I'm still on the same screen that I started with. I'm receiving all my traffic back, all my tests. It's telling me everything's running fine. And then when it's done, it's going to pop up the test results right over top the main screen. In this case, it's showing me my latency, what my jitter is, how many frames did I send, how many frames did I lose. All the critical information is right in the beginning, so you don't have to dig around and look for specific information. We think like a technician. This is all the information you need right up front, all the way down to total throughput. But what if you want to look at all the deep information as well? You can take your finger and just scroll up on those test results, and what you'll see is that we now have all our transmit pause controls, statistics, runts, jabbers, what the maximum frame sizes were, all that information that expert technicians are looking for. So we don't hide it from you. We just have to scroll down and look at it. And from a novice technician, you're probably not going to look at it anyway. What you want to know is how many frames did you send? How many did you get back? Were there any error frames? That's done. From a quick test standpoint, that means you're ready to test. So now this unit automatically stores its test results. So if I were to press next, I did one that had some errors, so I went ahead and pressed next. Now I'm looking at my previous test, and you can see that I lost 2,300 frames. So it stores the last 3 test results automatically for you on a quick test so that you can run a test and validate from a previous test to a new test, especially if you're troubleshooting. So we'll go ahead and say OK. So that's quick test. So now we know that we're configured properly. We're ready to run a test. So we want to do, say, an RFC2544. We can go ahead and press quick test, and now we can change that to RFC2544. Notice, same screen. We haven't left the screen, same one that we were on, so we're not lost. All our throughput, frame loss, latency, back-to-back setup, exactly like any other tester on the market. We just make it very, very simple for you. So in this case, if I want to turn on my throughput and frame loss, I tap on that, it gets a green checkbox. That means it's going to run that test. Say I want to do latency. Tap on latency, I'm going to run that test. Sometimes you do back-to-back, sometimes you don't. You can leave it checked or unchecked. So that way you can shorten the total duration of your RFC2544 if you don't need to be doing that test. As far as frame sizes, we can go and tap on frame sizes, and once again, you can either select all the standard RFC2544 frame sizes or just select a few of them. In my case, I'll do, say, 64, say 512, and maybe we'll do a maximum frame size as well. So let's see here. And say 1518. We'll do OK. Now that was our throughput and our latency. We set it all at the same place. So our throughput and latency are chained together. That's why it's a little bigger button there. Now the number of trials, it's always one trial for throughput, of course, and so it defaults to that. Latency, you can set however many trials you want. Most technicians are setting it to 1. The standard says 20. So that's what takes a long time if you're going to do it to the full standard. As far as duration, how long are you going to test each one of the frame sizes? 10 seconds. We'll leave it at, say, we'll change that to 5 to shorten down the test a little bit, so that way we're not standing here for a long time. So we'll go ahead and do that. Go to 5, say done. And same way, our max duration, our max load, our min load. So maximum load, we're going to test to 100% of the pipe. And then if we can't do that, we'll back down by a certain amount. Now that certain amount is set by your step. So our step is set to 10. So right now it's going to start at 100% or 1 gig. If it can't do 1 gig, it'll back down by 10%. So then it'll go 900 meg. If you can't do 900, it'll go to 800. Standard RC 2544. But if you set that step to smaller, say 1, now it's going to go from 1 gig to 999, 998. So it does increase the length of the test, but it does improve the resolution of the test as well. Now we can put in our test ID. So in this case, I'll just go ahead and I'll call it demo. Okay, we'll say done. And now we're ready to start our test, our RC2544 test. Very simple setup. Now we start our test. And what it's doing is it's showing that how far are you into the test. So it's showing what it's completed as far as throughput for 64. Then it'll go through, it'll do throughput for 512, and then 1518. And then when it's done, it'll move through. So we can see here that we've already completed our throughput at 512. As soon as it's done, it'll go on, it'll move on to 1518. And then when it's done with that, it'll display the test results. Now we're running not only a throughput test, we're running the latency test simultaneously. So that is a kind of a quick latency function. It shortens the amount of time it takes to do that test. In fact, as you can see, we've already completed our test. Just like quick test, our test results immediately pop right in front, so you don't have to go into menu after menu after menu. So here we have our frame loss, our testing. We can go to the next. We can see what our status is for our next result. This is our RC latency at our next frame size. We can go to next. We can look at our next one. So we can step through the tests as well. Now we can also go and look at our graphs. So we'll go back a little bit here and we can look at our view our graphs. And we can tap on here and you can see from the throughput as it ramped up in throughputs, and we can look at our frame loss. So I can look at my frame loss. Of course, it will be 0 because we didn't lose any frames. So everything's 0. And then we can say OK. And now we're back to our main screen. And that test result is saved right into the MobiOffice application as a PDF and a CSV. So that allows you to go into the device immediately, retrieve it. If you have email set up, because it is a full Android tablet, it allows you to send that test result right from your device as an email, or you can export it out via USB. So we have 2 USB ports on the left hand side. We also have an on-the-go port, or an OTG. That's just like a video camera where you can plug into the side, plug into your laptop. It looks like it's just another drive on your computer, and you can copy and paste your test results right out as well. So that's your RC2544 test. Now if I go down one more, we have also a loopback. That loopback is used for your 10 gig. So your 10 gig port, even though at 1 gig we have a dedicated loopback port, port B, 10 gig we use port A as our loopback. So if we were going to do a loopback, we would do loopback. IP Tools allows you to do ping, trace route, those standard type tests as well. So we'll go ahead back to 2544 because I think those other features are self-explanatory. If we take a look across, we'll go back to quick test here. Okay, and there we go. And that completes our demonstration of our DataScout 10G. if we at 1 gig. Now if I wanted to do 10 gig, we're on port A, so I would just do drop down. And here we have fiber 10 gig. I'm going to select my fiber 10 gig. We do support 100 FX too if you still use those. Don't have to worry about running into those too often anymore, but if you still have them in your network, they're available. So notice even at 10 gig, it works exactly the same as at 1 gig, or even if it was at 10 meg. Screen looks the same, nothing to be confused by. Up at the top, notice that the fiber now is showing not only, it's still showing the status of the copper ports because they're plugged in, but it's also showing the status of the fiber port. So we're showing fiber 10 gig, the link's active, and your loss is about neg 11.9 through the loopback plug. Pretty standard. So your setup is actually the same on 10 gig, works exactly the same. The only difference is if you're going to loopback mode, you would select loopback mode from this screen. A couple other things that we can do with Ethernet's pretty nice. So at the bottom of the screen, or at the bottom of the unit, there's 4 little icons. The third one over is your menu bar. So if I tap on my menu bar, it's going to bring up my menu, and it's going to show me my main screen. Sorry, I pushed the wrong button here, so let's go back again. That was my home button. So here I'm going to do my menu bar, and it brings up a menu bar across the bottom. So a couple things that we can do here. One, we're typically set to loopback mode, so we're transmitting out and we're looping back on ourselves. What if we wanted to do from point A to point B with 2 units bidirectional testing? Well, now what we need to have is end-to-end mode. So I'd go ahead and tap end-to-end mode, and it would show that it's on end-to-end mode selected. Now what's going to happen is we're going to have 2 devices on either side. When you start the test, it waits 5 seconds and both devices try and synchronize with each other. Once they're able to synchronize, then they start transmitting. And that way you look at your test results on both sides. I'll go ahead and put that back in loop mode. And then go back in. The other thing is we can look at our system information. So if I go in my system information, it's going to show what the platforms are, what the MAC addresses are. So that way if you're a technician on the far side and your other technician calls you and says, hey, what's your MAC address? Very simple. You go in, type in sysinfo, and now you can see exactly what your MAC address is without going through any menus. Last thing is we can show the status of the fiber optics as well. So in this case, I have an SFP Plus that's plugged into the 10 gig port. So I'm going to go ahead and tap on SFP Plus. And what we're showing is that it has, in this case, it wasn't able to pull information off of the SFP. I'm going to go ahead and do a refresh. Should be able to show it here. There we go. Sometimes you just have to refresh it to get that information off the SFP Plus. So in this case, it's showing the SFP Plus, what the model is, what the speeds allowed on it is, diagnostic support, the internal temperature, transmit, receive power, everything like that. So you can also turn off your laser from here too for safety. Now the last thing I want to talk about, and this is available not only on the 10 gig ports but also on the 1 gig port, is this little A to B button in the upper right hand corner. Now what that is very powerful. Not often that you're going to use it, but if you need it, very, very handy. It basically turns the DataScout 10G into a media converter. So one application, let's say that you're testing a 10 gig circuit on the network, but you only have a 1 gig circuit on your laptop and you want to be able to upload test results through that 10 gig port. Well, in theory, you could tap the A to B button, and what that does is anything, whatever speed is on A, it links it to port B as a multiplexer. So port B right now is set to 1 gig copper. My port A is set to 10 meg fiber. What it's going to do is it's going to demux up to 1 gig of traffic out of that 10 gig pipe, and it's going to drop it out to port B. So if we think about from a laptop standpoint, you could plug your laptop into that port B copper right into your laptop, and it would mux up your information off your laptop through the DataScout 10G into a 10 gig fiber port. That would allow you to send and receive data through that 10 gig port. Emails, get documents, communicate, things like that. So it also allows you to act as a media converter. I could come in 1 gig optic and I can go out 1 gig copper, or vice versa. Or come in 1 gig fiber and go out 10 meg copper, half duplex if I wanted to. System's more than happy to multiplex any signal stream going through. So sometimes you get asked what that A to B means. That's what that A to B means. So this concludes our demonstration of the Ethernet interface. Covered all the major features. One question we often get asked is, what about Y1564? In this case, we're working on Y1564 right now. Plan to have it done shortly. So as soon as that's ready to go, we'll re-update this video and we'll give you a complete demonstration on Y1564 and multiple stream testing up to 16 streams too. This concludes our demonstration. If you're interested in DS3, DS1, or ISDN, Datacom, DDS, look for the other videos and select those, and we'll go into those individual test interfaces in